Hi guys, welcome back to the channel. So today we'll be discussing about the today's lead code question, which is bag of tokens. Here we are given a variable which is power, and then one more thing is we are given a variable power, and then we are also given a score of 0, and then we have a bag of tokens which will be represented in tokens, and then token tokens of I denotes the value of that particular token at the ith index, and then we need to maximize this total score. We need to maximize this total score by doing some of the operations. Those operations can be like, if the token is unplayed, we can do we can do either of the things, like do the face up or face down. Face up means, suppose let's say if we have a power greater than or equal to token size, then we need to lose these particular tokens and then gain one score by adding the score to 1. And and then let's say if you want to do face down, then the score must be at least 1, and then you may play the token and then gaining the tokens of I, and then these tokens of I will be added to the power, and then we should lose one score for the particular operation. And then at last we need to return the what is the possible score we can achieve by doing these operations. So let's focus on the problem. So let's take this particular example where we have tokens of value is 100, and then we are also given a power of 50. As the power is not greater than or equal to values of I, we cannot do this particular operation, and then uh, we cannot do anything. So we'll be returning 0. And then let's take this particular example, and then for this particular example we'll try to use this particular power which is 150. 150 is greater than or equal to 100, so we can say that the power decreased to 50, and then after that score will be incremented to 1, and then we'll move to the next one which is 200. Here we have only 50, and then we cannot increase the score, so we'll be dropping on that, so we'll be returning one answer. So for this particular case which is 100, 200, and then 300, and then 400, here if we see at this particular place the power is 200, that means it is greater than or equal to 100. So we can say we'll reduce the power to 100, and then we'll increase the score to 1. So it will be, score will be 1, but the power is reduced to 100. Suppose if we come here and then the score the power is 100, and then tokens of I is 200, so we cannot do this particular operation to increase our score, but we have a score which is score equal to 1, so we can use this particular score to increase the number of tokens which are present at the right side. Why? Because let's say if you choose this particular operation, then we'll get only less number of tokens for reducing the score 1. And then if we use this particular operation which is to the right, then we can say those operations gives us the maximum tokens, so we'll use right operations instead of the left operation. So it will be increased to 500, and then score will be reduced to 0, and then after doing that we can use this particular tokens which are 500. 500 is greater than or equal to 200, so we'll do the operation, and then power will be reduced to 300, and the score will be increased to 1. And then again we'll do the face up operation for this particular case, which will be reducing the power to 0 and then increasing the score to 2. And then at last we are going to maintain this global variable which will score the maximum score, and then it is going to return 2. It is going to return the answer. So for this particular operations, let's focus on what is the algorithm. It is straightforward, like we'll take the left and then we'll take the right, and then we'll check whether we have this particular power to increase our score or not. If we doesn't have the that particular power, then we are going to increase via using this particular indexes which are to the right, and then we'll increase the tokens by reducing the score. After reducing the score, we'll get the more power, and then by using more power we'll see whether we can achieve these tokens to be reduced and then increased to score. So let's see the algorithm how we are going to focus. So for this particular algorithm, we are going to say the answer is going to be 0, and then current score is initially 0, and then we are going to take left pointer, and then we are going to take right pointer, and then it needs to be sorted. So the input cannot be in sorted order. So it can be in any order. So we are going to first sort, and then after sorting we are going to check whether the left is always less than or equal to right. That means we are checking the conditions such that left and then right pointer will not cross over. So if it crossovers, then all the elements which are present in the array is traversed. So we'll check that particular case. And then let's say if the power is greater than this particular tokens, then we can say that we can reduce this power and then increase the score. And then let's say if we doesn't have that much power to reduce the tokens and then increase the score, then we are going to use the rightmost elements which are present, and then we are going to increase our power by tokens of right, and then we are going to decrease that particular score. And then for every case there can be any scenario where the current score is maximum. So instead of returning current score, we need to maintain this particular answer which will store the maximum current score which we have in different cases. So for, and then let's say the power is not possible and then current score is not possible. That means we do not have enough current score or enough power, so we cannot proceed further. Why? Because let's say here I have power equal to 100, and then this particular tokens is 200, and then I have current score equal to 0. That means I I cannot use this particular power, and then I don't have enough score to get the tokens from the right side. So it is not possible to move from the left side, and it is not possible to move from the right side. So that means we are not able to proceed further. So we are going to break out of the loop, and then we are going to return the answer. Whatever stored in the answer we are going to return. So for this particular problem, the time complexity is going to be big of n log n. Why? Because we are sorting the array, and then we are doing the two pointers approach via big of n. So it will be big of n log n time complexity. And then if we see the space complexity, it is going to be big of 1. Why? Because we are not using any extra space. Maybe we'll use sort. Maybe if the sorting is using more space, then it is going to be big of sort, whatever the sort technique we are using. So whatever the space it is going to take, it is going to take big of sort. Yeah, that's all for this video. Thanks for watching the video. Bye.